Hello. In this video, we want to look at the instantaneous rate of change. So the instantaneous rate of change, hereafter denoted as IRC, for a function f when x equals a is, the instantaneous rate of change is the limit as h goes to 0 of the difference quotient. This is part of the reason why the difference quotient is so important. In other words, if the distance from the initial point to the next point goes to 0, that's what the instantaneous rate of change is, provided, of course, that this limit exists. Now, here is a nice representation of this. Here is just some function. This is my initial value here. Let's call that a. And notice that I've got different points here. Now, each one of these points, I'm going to kind of show you what it looks like for the average rate of change. So for the first one, let's look at this. So the average rate of change is about right there. So that's what the average rate of change would look like in terms of slope. Now for the next one, the average rate of change is that. Notice that the slope, this is a greater slope than this one, so it's actually reducing the slope here. From here to here, that's actually pretty much a flat slope. In other words, it's a horizontal line almost, if not exactly. And then from here to here, notice that it's actually decreasing the slope still, here to here. Now, notice what's happening. I can't even mark it there. What's happening is that this has a pretty decent change in the slope, and then a bit less, then a bit less, then a bit less. And notice that as I'm getting closer and closer to over here, I'm getting closer to a very important line, which would be this line right here. That right there is the instantaneous rate of change. And the reason it's the instantaneous rate of change is because it's the tangent line. It's a better term for it. You'll see why after a little while here. But it is what the function is doing if you zoom in a lot right there. And so if you zoom in really, 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 really close, it's going to look basically like a flat line, just like this. And really the instantaneous rate of change is the tangent line will just kind of graze the function at that point and then just keep going like that. So the slope of that line, though, is what the instantaneous rate of change is. Okay, so the slope for the tangent line is the instantaneous rate of change. Now each one of these is called the secant line, whereas the one that's representative of the instantaneous rate of change is called the tangent line. So here's what we have. We have the instantaneous rate of change. Let's start with the ARC. For the average rate of change, that is the slope of the secant line. The IRC is the slope of the tangent line. And what's important to understand is that the instantaneous rate of change is the average rate of change, but with the difference between each one of these x values. Notice that this x value is right here. The x value is right here. As we get closer and closer and closer to this value from over here, this is going to approach this line right here. So that's what the instantaneous rate of change is. It's what's happening at that exact time. Okay. Now the differences between the average rate of change and the instantaneous rate of change can be thought of as, say, driving to Amarillo. So here in Dumas, it takes, well, it's about 40 miles, right? It takes about 30 minutes to get there. So if you take that 40 miles divided by 30 minutes, then 40 divided by half an hour would be something like 80 miles per hour. And that would be your average rate of change. And you probably won't get pulled over for going 80 miles per hour, right? But what if you started out going kind of slow here, and the speed limit is 60 miles an hour here, right? So if you actually start out going 60 or 65, well, one of the two, whatever it is. So if you start out going 60 right now, let's just say 60, for about 10 miles, you're not going to get there in 30 minutes, right? So you're going to have to actually wind up going faster than you would normally, which means you might have been going 90 miles an hour at some point. So at an instantaneous point somewhere along the way, you were going 60, and at an instantaneous point somewhere along the way, you were going 90, so that whenever you're done with all that, you still get there in the same amount of time, which means that your average rate of change would still be that 80 miles per hour, your average speed, in other words. And so that's the difference between an instantaneous and an average rate of change. So the instantaneous is at every single individual point along the way, you have a certain speed along the way, right? But once you look at it as an overall thing, then you have your average rate of change. Now, that doesn't mean that you can't have an average rate of change that is the speed limit and not get pulled over. I mean, that means that if your average rate of change is the speed limit, you can still have been going really fast at one point and get pulled over, because your instantaneous rate of change at that point was greater than the speed limit. Excellent. So hopefully that helps you understand the differences between average rate of change and instantaneous rate of change. Now, there is an alternative form of the instantaneous rate of change. So it is for a function f when x equals a can be written as the limit as b approaches a of f of b minus f of a all over b minus a. So basically this is, again, just the average rate of change formula, and then we're just saying let b become a. Of course, all of this is provided that the limit exists. Alrighty. Well, with this information, I'm going to go ahead and end it here, and I will see you in the next video. Have fun.